Okay, so we're going to look at domain and range. I have absolutely nothing written here, but I have a graphing calculator we're going to look at. And we're going to focus on, they're called continuous functions, okay? So, with the continuous function, I want this to turn on. Here we go. Okay, so we have x equals y, and you don't have to really worry about the equation of it. You just have to take a look at how it looks. So with our x values, they essentially are going right and left. And it looks like this one's going to go forever to the right and forever to the left. So when we do something like that, it's called a continuous function. Okay, so oops, let's no. Please. There you go. Okay, so because it's a continuous function, we're going to start off with domain of x ER. X is the element of all real numbers. What it's saying is it spans everything, every single number you can possibly think of, whether it's 1, 2, 3, 4, 1.1, 1.001, all those things, right? And then we have to give it some kind of parameter. Now, because this one's continuous forever, we don't actually have to give it this parameter here. But we're going to, because sometimes it's easier to just do the exact same thing over and over and over again. And if you notice, if it goes on forever, well, the number that represents forever in a positive direction is infinity. And the number that represents forever in the negative direction is also infinity. I keep doing that. So we can say such that x is greater than and equal to negative infinity, which is represented, like you said, like a sideways 8, and it's less than and equal to positive infinity. Again, normally you don't have to write this. You can just say it represents everything. But if you really want to do the same thing over and over again, this is a good habit to get into, knowing that I always got to put restrictions, okay? And then the same thing goes for up and down. Okay, since the y values, this is going up forever and down forever, we set up the same thing. I really gotta stop doing that. Okay. We have y is the element of all real numbers. We can leave it at just that, or we can add the restriction that y is greater than and equal to negative infinity and less than and equal to positive infinity. For example, we have a quadratic. Okay, this is exactly what you're doing right here. And in this one, if we look right and left, let's turn this highlight on. Okay. It's actually, even though it's really hard to see with a quadratic, it's actually going left and right forever. Okay, even though the arrows aren't there, there's really nothing that's going to stop it left and right. So it's going in that direction forever. So when we go to write it, we got to use the same function notation we had before. So let's take a look at that. Okay, so we know that the domain, same as above, we can write it just as this, or we can copy what we had above. So we know it goes all the way left forever and all the way right forever. Since it's continuous, we're going to have YER again, but this time there's going to be a restriction with our value here. So let's try to figure out what the restriction is going to be. It looks like it goes up forever, but it has some kind of stopping point on heading downwards. What's our lowest value for y right now?
0.
0, okay? So 0 is our stopping point. So it's going to go up forever. And what number do we represent for up? What were we using? Forever, sorry? Yeah, infinity. So it goes all the way up to infinity, but it only comes down to 0. It doesn't reach all the way to negative infinity. So when we go to write that, we would say that the lowest value is 0, right? We said 0 is our lowest value. And the highest value is infinity. Again, normally you would only kind of write this part here. This would be irrelevant. But you can write it in so that you get into the exact same feeling every time. So now that we kind of know this idea, we can kind of jump ahead here and see if we can figure these out very quickly without me having to really draw much. Up and down, this one's going to go forever. So what's it going to be?
Just infinity.
Infinity and negative infinity. How about left and right? Is there a stopping point left and right?
Yeah, there's a stopping point going left at 0.
At 0. So 0 would be our lowest value, right? Going left. And what would be our highest value?
Infinity.
Okay, and up and down, our highest value was,
Infinite.
and lowest value was
Negative.
perfect. So now all we have to do is get used to writing it in that special notation. So let's take a look at it very quickly. We said that, I don't know if I even remember it. There was a stopping point on the left at 0, and to the right it went to infinity. And for up and down, there was nothing stopping it. It went all the way up, and it went, sorry, all the way down and all the way up. Let's look at a tougher one. This one here is tougher. Okay. Okay. Going to the left, does anything stop it? Nah, it looks like it's forever. So it looks like negative infinity to the left. How about to the right? This is where it's tricky.
Not really.
Yeah, it doesn't look like it's going to reach, but it actually is in this function. So it's kind of a terrible example for that, but there's something else I wanted to use it for. Okay, so it does technically reach to positive infinity. In terms of upwards, is anything stopping it? No, so positive infinity. Downwards, it's stopping. Where do we think it's stopping going downwards, though?
About at 0.
Yeah, it looks like it's going to stop at 0, but it's not quite. It's just going to stop just before 0. So 0 is going to be our value, but when we go to write our notation, something's going to be a little different. Okay, and I'm going to show you what it's going to be. It's going to be a little different here for our, it's called an exponential function. Left and right, it was going forever, so we're pretty used to that. Negative infinity, less than and equal to x, less than and equal to positive infinity. Up and down was where it was tricky. So 0 was the value. I'm going to put the y in, and we said it's less than and equal to, it goes up forever, positive. But it's not going to be equal to 0 because it's not technically touching 0, so we don't draw that little line in below. Okay, and your teacher probably won't get too picky by that, but that's just another example of how to use that. This means it's also touching. It means it's also equal to. In this version, it doesn't technically touch 0, so we don't write that line. Okay, and then the last big example we have here is our wonderful circle. Okay, so this one definitely has stopping points. How far to the right does it go?
To 4.
4. And to the left?
Negative 4.
Great. Up?
4.
Yep. And down?
Negative 4.
Great. So instead of using any infinity symbols, they're being replaced by numbers because nothing's going forever. It definitely has stopping points. So let's take a look at what those stopping points would be here. When we go to write it in. Number 5. We have XER such that negative 4 was the lowest, and positive 4 was the highest, and YER, exact same idea. Negative 4 and positive 4. There we go.
Can't you figure that out?